How do I solve a proportion? Factoring. Quadratic formula. All coming back. All right, so those three things. How do I solve a proportion? A reminder on how to factor. And then if I can't factor, how do I use this thing called quadratic formula? So some of you, yes, if you have a calc on you, let's get it out. We're definitely going to need that today. And throughout the entire unit, that's not going to change anywhere. Let's also talk about the calc situation right now. Midterm, I have 70 geometry students taking a midterm and 3 extra calculators. Who do I give those 3 to? That I don't know. All right, so if your calculator situation where you always happen to borrow one of mine, which is fine during the year, it doesn't bother me, but during the midterm, I have 70 students and 3 extra. That's not good math right there. Okay, the chances of you getting an extra one if you needed it. So you have 3 weeks from tomorrow. That's the midterm. 3 weeks from tomorrow to figure out a calculator situation. All right. All right. So let's go to goal number 1 here. How do I solve a proportion? First, what is a proportion? 2 fractions equal to each other. Okay, 2 fractions equal to each other. There's my proportion. How do I solve it for a variable? This is all review, I hope. How do I solve it for proportion? Oh boy. Help me, Claire. Cross multiply, yes. Sound familiar? Cross multiply. So number 1, what do I mean by cross multiply? I take the 5 and the n, multiply them and get 5n. I take the 2 and the 35, multiply them and get 70, and I can't help you from there. All right, solving for n from here. Divide 5 on both sides, n's going to equal 14. So that's all we're going to do today is cross multiply. The problem is going to be right here, is it's not going to be as easy to solve as that was. So let's keep going. I still want you guys to feel happy until I just crush your souls and dreams here. Number 2, go ahead, cross multiply. All I want to know is what you get on each side after you cross multiply. Over here. Oh, 14. What do you get on each side when you cross multiply?
3x equals 2x plus 2.
Perfect. Make sure it's plus 2, not plus 1. And those can be flip-flopped. That's fine. Maybe you cross multiplied the other one first. Now go ahead, solve for x. Let me know what you get when you solve for x. 7. 2. Yep. Any issues? All right, now we're going to get a little bit more complicated when we solve for x. Wait a second. Number 3 is not even a proportion. That's a fraction, but x, that's not a fraction. Oh, yeah, it is. We just don't see it. What's it over?
1.
Darn right. Now we can cross multiply. I'll do the easy part. 1 times 13. Ooh, you ready for the next cross multiplication? Little, I don't even think it's last year. You guys probably did this in 6th and 7th grade. X plus 6, x minus 6. When you multiply those two, how do I treat that? I don't like the word, but some teachers use the word FOIL. First, outer, inner, last. So ridiculous. Double distribute. That's how I roll. You're going to distribute twice. First, we're going to distribute the x. Ready? X and x. Yeah, it's not 2x. Get out of here. X and negative 6. Negative 6x. There's one distribution. Ready for the second, a.k.a. double. 6 times x. And 6 times negative 6. All right, and look what happens in the middle. They cancel each other out, right? So I'm left with 13 is equal to x squared minus 36. Oh, a little bit tougher than 5x equals 70. What's your next move? I'm going to move the 36 over. A couple people last period. Square root each side. No, not until the x squared is by itself. You can square root, which it's not, so that's why we are adding 36. Nice little number there over on the left, huh? 49. Now I can do what? Now that it's all by itself. Square root. And here's where all of us are going to fall into the second trap. You're only going to get half credit for this one. We're missing something. Hi, John.
X equals -7.
When you take the square root of a number, you get the positive and the negative version. Watch out for that. When you take the square root of a number, you get the positive and negative. And is it all right if I do this? Plus or minus? You can write -7 and 7 out. That's fine, but I like rolling with that. All right, we all right? X equals plus or minus 7. Ho ho! What if I can't take the square root? Go ahead, cross multiply for me. What do you get on each side? 7. Again, when you're ready, what do you get on each side? Okay. You can't, this is not going to be a square root problem. Here's why. Okay, I get it. You got a squared here, but you also have something that just has an x. When those two are in the same problem, you can't square root, but you can factor. And look, I'm going to fly through this. We've been factoring all year long, and I'm not changing the method of factoring either. It's going to be the same method, just not right now. I don't want to factor right now. Why not? Not ready to. You're not ready. Why not, Nick? Okay. And that's it?
And then you have to move the 5x and the 30 over to the left.
Doing a lot of moving. You might need a U-Haul for that. How about I just move the 5x and the 30 over? Leave the 2x where it is. Got to be equal to 0. You can't factor unless it's equal to 0. And look, if your x squared's positive, leave it that way. Leave it positive, please. I don't know how to factor negative x. Oh, I do, but I prefer not to. Anything that's negative x squared. All right, so yep. So let's move the 5x and the 30 over. How? 15? How do I move the 5x and the 30 over? Darn right. X squared minus 5x minus 7x. One job. I like this is the third time I've done this problem today. 7x minus 30 equal to 0. Good work, everybody. Now factor. This isn't, I'm not going to show you a new method. This is the same method all year. Two numbers that. Add to 7, but at the same time, -7, but at the same time, multiply to -30. Get after it. Two and 15, no. 6 and 5, not getting a 7 out of that. My two numbers, 7. Oh yeah, on fire today. -10 and 3. Yep. Now I need to actually know what x is. So some of you guys know what it is already. Some of us, though, may need to just take it out of the parenthesis and set each of them equal to 0 and solve for x. So the two answers, sometimes 1, sometimes 2. 2, what are my 2 answers? Number 2. One job. 7. Thank you. All good? All right, go ahead. Number 2. Looks like, yeah, I got a little double distribute, huh? When you double distribute, hopefully you ended up with the x plus 3x in the middle and a 4x overall in the middle after you combine. And then now it's time to get one side equal to 0. Again, my x, see how my x squared's positive? Keep it that way. So I'm going to move 3x and the 15 over. Minus 3x minus 15. So I should get a positive x in the middle and a negative 12 on the outside here. Factor time. I don't know why I needed that. 10, numbers that multiply to negative 12 but add to 1.
Up to 4, negative 3.
Whew. Yep. So my 2 answers for x. Whoa, 19.
-4 and 3 and +3.
You got 3 on. Don't go to number 4, please. We're not going to do number 4 as a class. So number 3, go ahead on your own. See what you got. Cross multiplication's not too bad. -5, +4. Look good? Questions? It's not that funny over there. It's probably not. Any issues? All right, now here's what's gonna happen now. You guys are gonna cross multiply, set it equal to 0, but then you're gonna go to factor, and you're not gonna be able to find those two numbers. They don't exist. But I'm still gonna ask for values of x. So what happens if they don't exist, these numbers? You need the quadratic formula. All right, you're not ready for it yet, though. You're not ready for it. You don't deserve it yet. You need to pass a couple tests before I give it to you. Breaking down a radical. Prove to me, we've done this all year long. Prove to me that we can break down a radical. Can we review the perfect squares before we do, so we don't have attacks here? 4, 9. I'm not memorizing these. I'm doing 2 squared, 3 squared, 4 squared. So the next one, 25, 36, 49. One more, 64. All right, now let's go. Breaking down square root of 72. What are you looking for here? The highest perfect square that goes in without a remainder. No decimal. The highest one, the biggest. Not 8. Not 9, because it goes in the first one I found. There's a bigger one than 9. Let's find it. $22. Biggest perfect square that goes into 72.
It's 2 and then under the radical 6. I mean 6 and then under the radical 2.
Okay, I didn't ask for a hero. I don't need the final answer.
Oh.
I just want to know the.
36 and 2.
Okay, 36, biggest perfect square, and 2. Thank you. And there's a reason why we pick a perfect square, so you can take the square root of it. 36 becomes 6, and then the radical 2 is in my answer. Go ahead, square root of 32, before we get nuts. Biggest perfect square. 15, biggest perfect square that went into 32.
16.
16 times 2. So we end up with 4 square root of 2. All good. All right, now let's play around now a little bit. Let's go a little bit more in depth than just breaking down a radical. Square root of 48 over 2. My first question is, can I just write this? Oh, 48 divided by 2, that's 24. I'm good. You cannot. Here's why. Here's why. If I do square root of 48, that's a totally different number than 48. So do you see why I can't divide it? All right, you cannot divide a radical with a number. It's not going to happen. So what do I do instead? Simplify it first. Go ahead. We got plenty of practice in this. Break down radical 48. That's all I want you to do. You got to break it down. I'll take your test. Thank you. Thank you. Yeah, no problem. All right, break breaking down 48 for me. What 48 break down to so I can replace it? Oh, 11.
16 and 3.
So 4
And radical.
radical 3. Everyone's good? Over 2. Now you can divide. You just can't divide a radical and a number. I can divide 4 over 2. So this will reduce down into 2 radical 3. So that's what I'm going to have to do first, is break down the radical and see if I can divide. Number 4, again, I can't divide these two. One's underneath the radical and one's not. Not going to happen. But I can break down square root of 150. Go ahead. Biggest perfect square that goes into 150. Broke down 150. Ready to go? What do you got? Ones again. 11.
5 radical 6.
5 radical 6. That would have been 25 and 6. Over 5. 5's divide, and it's just going to be radical 6. I'm having you do this because I'm going to have you do this at the end of quadratic formula when we're done using it and simplify it all the way. Any questions about when I divide? All right, now you deserve some quadratic formula. Good news. I'm going to give this to you on the test next week. You don't have to memorize it. No need to memorize it. Okay, I will give it to you. No need to memorize. I would have a problem if I'm some of you. Here's my issue. I am a factoring beast, a stud, or the opposite of some of the guys in here. Too harsh right away? I've got 5 weeks built up. All right, 5 weeks built up that I got to get out. All right. Why can I not just Why are you forcing me to use quadratic formula? Why do I need to use it if I could just factor it? Here's why. Take a look at this first example. X squared plus 2x minus 1. You're like, here we go. Get my little parentheses out. X and x. I'm looking for two numbers that multiply to what? -1, but add to 2. And I'm like, all right, well, the only two numbers I know that multiply to 1 are 1 and 1. See my problem? I try to make these add to 2. It's got to be plus and plus, but what's the issue? These don't multiply to -1. See what I mean? So you might be a factoring beast, but you can't factor. You can't. It's impossible. But I'm still looking for a value of x, so that's why I need to use quadratic formula. Okay? All right, so how do I use this bad boy? And why do I have this random line here pointing to roots? Because I just wanted to remind you that roots is another fancy word in mathematics for solutions. All right, just asking for the solutions. So all you factoring studs out there, you can't. I have to use quadratic formula. And in quadratic formula, you notice an A, a B, and a C I got to plug in. Where do I get those values from? The equation when it's equal to 0. Still got to be equal to 0. That doesn't change. So where's this A value located? It's the number in front of the x squared, which in this case would be 1. B would be the number in front of the x value only. 2. And C would be the constant, the number without a variable. -1. So everyone all right identifying those three before we substitute in. All right, so here it is, quadratic formula. I'm just going to plug in where I see A, B's, and C's. X equals, what gets in for -B? What am I going to plug in there? I know what my B value is, but it says plug in -B. 28, what's going in there? 2. -2 plus, or why do I have a plus or minus? I'm going to have two answers here. Two answers. Square root, and honestly, this is where I get fired up. The most common mistake using square roots with students is the number underneath the radical is always incorrect. Here's how we're going to avoid that. What do I plug in for b? 2, but I want that darn thing in parentheses underneath the radical. And I'll show you why. 2 squared minus 4 is 4. What gets plugged in for a? Plug it in parentheses underneath the radical. What's get plugged in for c? Put it in parentheses. All over 2 times 1. I don't want decimal answers. I want radical answers, radical form answers. So if you have your calculator on you, all I want right now is what number should be underneath this radical here. I got pretty fired up when I said parentheses, right? That's because I want you to put them in your calculator too. If you wrote them on your paper, you put them in your calculator. Parenthesis. What was it, 2 or negative 2?
2.
2 squared minus 4 parenthesis
1.
times parenthesis.
-1.
What number goes underneath the radical? 8. Okay? I can't tell you how many kids try to be superstars and try to do it in their head or on their own, and it's a totally different number. Use parentheses in your calculator. So 8 goes underneath. I don't care what the square root of 8 is. We're going to simplify that. And what's in the bottom? 2. All right. I know the directions don't say here, but most of the directions are going to be simplest radical form. Break down the 8. That's why we did all that work. This is why you deserve to use quadratic formula now. Break down the 8 for me. Just radical 8. Break it down, and we're going to replace it. So -2 plus or minus, break down 8 now. Just like we did before. Just like you did with 72 and 32. So final radical, what's it simplified to? Oh, 8.
2 radical 4.
2 radical. Hey, thanks. We're ready to roll right now.
That's
Let's
right.
go. 2 radical. Well, here you go. You get radical 4 and you get radical 2.
2 radical 2.
2 radical 2. Everyone's good. Just replace it over 2. That's not simplified yet. The radical is, but your fraction's not. Here's how we're going to end it with quadratic formula. We are going to separate, see the plus and minus? We're going to separate it into 2 fractions. Right now it's 1. We're going to separate it into 2. The first one is what's to the left of the plus or minus? -2 over the denominator, 2. Plus or minus, what's to the right?
2 radical 2.
2 radical 2 also over 2. We're going to split it up. Now reduce. Now reduce. After you split it up into 2 fractions, now reduce. Oh boy. 5, help me out. -2 over 2.
Sorry, -1.
You're fine. -1 plus or minus.
Radical 2.
That's it, right? 2's cancel. Radical 2. That's your answer in simplest radical form. I will never have you do this, but I want to talk about it. I want to talk about it because it's going to help down the road. What if I had you split this? Because we said there was 2 answers, right? 2? How do you split it into 2 answers now? How would you write it? How do I split it into 2 answers? Max?
You make like -1 plus radical 2.
There's 1 answer, and then -1.
Minus.
There you go. That's what your 2 answers would actually be. Good. Any issues? Break down the radical, and then break it into 2 fractions. All right, number 2. 1 doesn't make you great. I'm not doing anything with quadratic formula. Why not? I'm not doing anything here. I'm not ready yet. You're not ready for quadratic formula. Why not? 10.
You have to subtract the 5x over.
Thank you. And darn it, put it in the right order. Don't just leave it hanging on the outside because you're going to get your A, B, and C values mixed up. Minus 5x in the middle, minus 1. Oh, wait. Oh, remember, I'm Mr. Tough Guy. I can factor anything you throw at me. Why do I not want to try to factor this one? Anybody see anything that's there that's never been there before? Yeah, that's usually a 1. Not going to factor that. All right, I'm not reviewing how to factor something's not a 1. How do I do it? I only do when there's a 1 out in front. So it is time to use quadratic formula. I'm not a big fan when there's a number out in front. All right, little help. A, B, and C. Let's roll. 8, A value. Number out in front of the x squared. B value. Number out in front of the x. Sign travels with it. -5. C value. The number without a variable. -1. Everyone's all good? All right, let's keep grinding. X equals, what's going to be in place of -b now? What's getting plugged in? 22? I got -b.
Wait, what was the question?
What's your b value?
It's -5.
So when I plug it in, what's it going to become to -b?
25.
Oh.
Oh wait, are you asking -5 squared?
No. I'm not even underneath the radical. I'm doing x equals -b. What gets plugged in here?
Oh, +5.
+5. You can thank your mate for that. Plus or minus. So we're going to get to what happened with the whole pen thing sooner or later, by the way, back there. All right, on the floor. We'll find out. Next up. You ready? Underneath the radical. B squared. Put it in parentheses underneath the radical. -5 squared minus 4. A value is 3 in parentheses. C value is -1 in parentheses. Anything that gets put in underneath the radical, put it in parentheses. And on the bottom, what do you got? 2 times 3. All right. Find me that number underneath the radical, please. This is definitely one place you could get this number wrong if you don't use parentheses. When you have it, let me know. 7. 37. Yep. Over 6. Any issues getting the 37? Now we break down, right? We try to break down the radical. Radical 37. Yeah, let's go get them. 37. Anybody find it a perfect square? That goes into 37. Okay, well, it's gonna happen. Welcome to honors. It's gonna happen. You can't break down the radical. So if you can't break down the radical, there's nothing else to simplify. This would be our final answer. You can't break down the radical. Don't try anything else. Whoa! What if I wanted you to separate it into 2? What would that look like? 5. And 5. There it would be. I'm doing this for a reason. I'm setting you up for the next couple days. All right. I think I can actually let you do one on your own here. I don't know if any studs tried to factor that. You weren't going to find two numbers that multiply to 2 and add to 5, so that's why we have to resort to quadratic formula. $17 underneath the radical. How's that look? 17. Can you break down 17? So as we talked about in the previous problem, that's it. Can't break it down anymore. If you can, you break it down, you separate it into 2 fractions and reduce. Final thing, I just have a note on here to remind me to let you guys know that when you go to classroom tonight, you're just going to find answers, and I did that on purpose. I want to see how you got to those answers. All right, so you show me your factoring, show me your quadratic formula, please, tonight. Show your work.